We are dripping wet water. In this video, we're going to discuss one of the biggest challenges in water treatment, biofilm. We'll explain why biofilm forms, how it survives, and why it continues to cause problems in water systems around the world. In water treatment, our attention is on the water. We treat it. We test it. We worry about it. Whether it's a cooling tower, a membrane system, a food processing facility, or an animal drinking water system, our goal is to improve water quality. But while we're focused on the water, the surfaces in contact with the water are overlooked. What you don't see is bacteria attaching to those surfaces and forming biofilm, where most bacteria in a water system actually live. As long as there are bacteria in the water, there will be biofilm. This is what you expect your systems to look like. Clean equipment, clean surfaces. No obvious problems, but appearances can be deceiving. Biofilm develops on every wet surface in a water treatment system, including piping, equipment, filters, membranes, and dead legs. These areas are often hidden from view, making biofilm easy to overlook and difficult to recognize. In a potable water system, for every liter of water, there are 500,000 colony-forming units. Think of how many liters of water you have in your system, as well as how many liters pass through your system every day. Every single one of those 500,000 bacteria has the capability of starting a biofilm. Once those bacteria have established themselves and formed biofilm, which happens in every water system, things get complicated fast. The shocking reality is that the bacteria in the water only constitute 20% of the bacteria found in your system. The real threat lies on your surfaces, where 80% of the bacteria are found. In our example, if there are 500,000 colony-forming units in the water, that would mean there are 2 million colony-forming units that remain hidden, ignored, and waiting to contaminate your system. Biofilm thickness varies significantly depending on flow conditions, nutrient availability, disinfectant residuals, and system design. Some systems may develop only a thin layer. Others can develop biofilms hundreds of microns thick. The important point is that biofilm can exist long before it becomes visible. Even relatively thin biofilms can contain large microbial populations and create operational challenges. By the time you react to the biofilm, it has already made your system a home. Biofilm exists for one reason: the survival of bacteria. Bacteria naturally seek stable environments where they can attach, protect themselves, grow, and spread, transforming individual bacteria into a highly organized community designed to survive environmental stress and disinfectant exposure. Biofilm is essentially an impenetrable fortress built by bacteria. Water treatment companies and municipalities do a very good job cleaning and treating water. However, clean water does not mean clean surfaces. Biofilm remains attached to equipment even when the water is clean. For many years, the industry operated under a simple assumption: if you treat the water with a biocide, you're also treating the biofilm. The strategy was straightforward: treat the water, control the bacteria, and the biofilm will take care of itself. When contamination persisted, the response was more of the same. Add more biocide or mechanically clean accessible surfaces. Today, we know that assumption is incorrect. Treating the bulk water does not mean you are treating the biofilm attached to the surfaces. But why doesn't treating the water treat the biofilm? Biofilm is not just passive microbial growth. It actually has mechanisms that allow it to defend itself against disinfectants, and weapons that allow it to attack clean water and surfaces throughout the distribution system. Biofilm's key defense mechanism is the EPS matrix. This impenetrable sticky protective layer surrounds the microorganisms and prevents many disinfectants from penetrating the biofilm. Its negative charge repels biocides like chlorine and bromine and attracts minerals such as calcium to build scale. Its hydrophobicity repels water and anything that can penetrate it. Its sticky, protective gel-like composition captures particles, debris, and nutrients, further strengthening the biofilm structure. Biofilm also has a way of attacking clean water and spreading on the surfaces throughout your distribution system. Bacteria within the biofilm can signal sections of the film to detach from the surface, releasing microorganisms to contaminate the water and forming new biofilm downstream. There is no way to predict when detachment and further contamination will occur. This unpredictability makes the continuous treatment of biofilm critical. Clean water does not mean clean surfaces. Biofilm remains attached to equipment even when the water is clean. The water in your toilet is the same as the water from your kitchen faucet, but you wouldn't drink from the toilet.
Why?
Because no matter how clean the surface appears, you know it's contaminating your water. In industrial water treatment, we often ignore the surfaces, and this results in contaminated water. A clean water system requires both water and surface treatment. As you have learned, biofilm is a big problem in water distribution systems. To treat the problem of biofilm, chlorine dioxide is the best solution and most effective cleaning agent. Chlorine dioxide is a weak oxidant, a dissolved gas, and is effective across a wide pH range. Now, let's look at why chlorine dioxide works. Biofilm has a negative charge. Chlorine dioxide is neutral in charge, so it is not repelled by the EPS matrix. Biofilm is also hydrophobic. Chlorine dioxide is a dissolved gas, which allows it to penetrate the biofilm matrix. These unique properties disrupt the EPS matrix and allow chlorine dioxide to break the bond between the biofilm and the surface. While chlorine dioxide itself is highly effective, the challenge has always been generating it safely, efficiently, and at high purity. Through our patented catalytic technology, Cloex generation systems utilize a safe and controllable reaction to produce a high-purity solution at low concentration and high conversion efficiency. By eliminating many of the traditional drawbacks associated with chlorine dioxide generation, Cloex delivers a high-purity solution specifically designed for biofilm control and water treatment. We hope you now understand the importance of clean surfaces in a water treatment system and how Cloex technology ensures superior biofilm treatment for water treatment success. Thank you for watching. To learn more about Cloex technology, please explore our other videos. And always remember, don't run clean water through dirty pipes.